All right, so this video we will be multiplying complex numbers in polar form. So we've already multiplied complex numbers before, but now they're going to do in polar form, and it's a very nice formula. So we have our first complex number in polar form and our second. And so you can notice the formula for it is just multiply the radii and add the angles. That's it. So we end up with r1, r2, cis theta 1 plus theta 2. So multiply the radiuses, the radii, and add the angles. So here's why. So you have r1 and r2. So we get r1 times r2, and then we're going to multiply the middle. So cosine theta 1, cosine theta 2, and so on, just foiling it out. And then you can see these all have i's, so we're going to put these two together. And then the I squared will turn into a negative 1, so we'll put these together. So we're going to put the real parts together and the imaginary parts together. And if you notice the imaginary parts, well, that's just the additive identity for sine. And the real part is the additive identity for cosine. So we end up with this. Pretty cool, right? This nice formula. So it's just a nice thing. Anyone says that math is not beautiful has never done math. It's a very cool. So we do 2 times 5. Those are our radiuses. And then all we do is add the angles. All right, and so the short form of this would have been 2 times 5, and then you just do cis 45 cosine I sine 60. And so then we write the answer as 10 cis 105 degrees, and that's it. And so what's really happening here is if we were to change this back into its rectangular form, it would look like this. So these two really messy things, we multiply them together and we get this, which is this. So if you check what we have here, 10 cis 105 is the same as that horrible looking thing. So let's check it in the calculator just to see what I'm talking about. So this would be 10 cosine of 105 plus I with a 10 sine 105. So if I plug those in the calculator, you'll see it'll give us the same two numbers. So 10 cosine 105 and 10 sine 105. See? Negative 2.588 plus I 9.659. See? Same answer. So it's a really cool situation. So this is all we're doing. We're putting it in that form. Okay. Let's try another. So this would just be 7 times 2, and then you put cis 300 plus 120. And so it's 14 cis 420. And then again, we want these to be in 0 to 360. So we minus 360 to put it back into its correct coterminal angle. So that would be 60 degrees. So this is in polar form. So how do you convert it back to complex? We just expand it out. So it's 14. And then it would be cosine of 60 degrees plus I sine of 60 degrees. And then cosine of 60 is a half. And sine of 60 is rad 3 over 2. So 14 times a half is 7. And then 14 over here would be, so we're going to put 7 plus 7i rad 3. And again, I've already done the work, so I converted it into its rectangular form, multiplied it out, and look at what we got. I forgot the I. And there we go. Same exact answer. So if I were to take this thing and multiply the whole thing out, you get this. And so obviously this is a little bit quicker if you already know the polar form. And if you don't know the polar form, converting it back could still be a little bit quicker. This is very, very fast. But this is what's really happening. So if you have 1 plus I, what we're going to do is convert it into its polar form and then use this formula. So 1 plus I we know would be 1, 1. So r squared is equal to 1 squared plus 1 squared. So r is equal to square root of 2. And theta will be the inverse tangent of 1 over 1, which is 45 degrees. So again, location, we're in quadrant 1, and so everything is good here. So we would have rad 2 cis 45 degrees. Let's do the next one. 2 minus 3i. And so r squared would equal 2 squared plus 3 squared. So r is the square root of 13. And then theta equals inverse tangent of negative 3 over 2, which is not nice. So let's calculator it. Inverse tangent of negative 3 divided by 2 gives us negative 56.30. But again, we want this to be within 0 to 360. So if we add 360, we get 303.69. So 303.69. So that would give us rad 13 cis 303.69. So those are R2. So this would be rad 2 cis 45 times rad 13 cis 303.69, which then would be rad 26 cis 348.69. And to keep these nice and exact, I'm going to plug that in the calculator as well. So plus 45. And so there's our angle together. And so this is our complex form. So if we change this back now, we would get this. So we're going to expand it out. So it's rad 26 cosine of 348.69 plus I sine of 348.69. And we plug that in our calculator. So square root of 26 cosine. And you notice I have to enter that in, right? So we don't want to do that. What we're going to do is square root of 26, and we're going to grab it. So cosine, scroll up, hit enter, and that way it's the exact answer, parenthesis, hit enter, and we get 5. So our real part is 5 plus I, and then now we just have to do the other one, right? So second square root of 26 sine, scroll out, sine, try that again, sine, grab it, hit enter, and it says -1. So I'll put the 1, why not? So you notice I've already taken that problem and multiplied it out, and we get this. It's very quick to do. It gets horrible when we're up here in these problems, but with normal complex numbers, it's just a lot easier just to multiply it out yourself. Don't do this. This is really cool, is all it is. But if it's in polar form, go for it. It's really good. It's nice to have both, but it's a really cool little thing. So that's it. There's every single situation you're going to run into. We got something here where we had a change, and then we have two complex. So if you were going to do this, you'd still have to put the polar. Now, does that mean you'd have to, or could you cheat? Yeah, you could multiply these two out and then just convert that back into its polar form. That's all it really is. So we're just going back and forth between the two. And so that is our polar form, and that is our complex form. Well, our rectangular form of our complex number. All right, thank you.